Hi, today we are going to present the English workshop, sponsored by my colleagues Gustavo Andrés Rono Hoyos, Eduardo Santiago Reina Narváez, Juan David López Andrade, and me, Valeria Rincones Arellano. He was sponsored by Daniel Bernoulli in his The Dynamics work in 1738. The Bernoulli principle is a statement that seems to go against intuition about how the speed of a fluid is related to the pressure of the fluid. Many people feel that Bernoulli principle should not be correct, but this is due to understanding of what the beginning says. Bernoulli's principle establishes the following. Within a horizontal flow of fluid, the fastest points of the fluid will have lower pressure than those with a lower speed. Equation of Bernoulli in a velocity of the fluid in the considered section, a density of the fluid, P, the pressure along the streamline, and G, gravitational gravitational acceleration.
For this exercise on the Bernoulli equation, which has a statement. There is a flow of weather through a tube that changes dimension at a point. Section 1 of the tube is 25 millimeters in diameter. The pressure at this point corresponds to 345 kilopascals, and the velocity of the flow initially is 3 meters per second. Section 2 measures 50 millimeters in diameter and is located 2 meters above section 1. If we assume that there is no loss of energy in the system, calculate the water pressure in section 2. In the table, we can see that two formulas. The first is Bernoulli's equation, and below this is observed that pressure 2 is clear, and thus we obtain the final formula with which we will work. In the low part, we can see the data that we are going to replace in the final formula. It's also seen that we do know the value of velocity 2. So we will use to the continuity formula that says that flow 1 is equal to flow 2 and flow is equal to velocity multiplied by the area. Already with this data we can also for velocity 2 and we obtain its formula and thus be able to replace data. Obtaining that velocity 2 is equal to 0.75 meters per second, and, and therefore we no longer have another unknown, and we substitute in the final equation and obtain it as a final result that the pressure in the section 2 is 329.6 kilopascals. Thank you.
Obtain equation general of energy for flow. Although equation of Bernoulli is useful for main problems, it cannot solve problems that contemplate energy that is added to it or that is extracted the accessor that is main hub. Losses as friction, el valve, engines y turbines, y addition as bump. The equation general energy is an span of equation of Bernoulli which the difference that there are loss and addition of energy. HA. Energy added by mechanic Davis such as bump. HR. energy stolen as engines, turbines, cylindric, hydraulic. EHL loses energy present in the system hydraulic as friction and accessors.
And then we have the exercise. The first step is to read the exercise and get as much data as possible. In this data, we consider the pressure, the volume, the constant key, and other things. The second step is to write the general energy equation and cross out the things that we will not need, like the HA and HR, that there is no in the problem, these values, and the speed 1 over 2 per gravity and the speed 2 over 2 per gravity, because both are the same. For that reason, we can cross out both speeds. Then we have to clear and replace. In this part, we use the values that the problem gives us, the values that we already know, that like the pressure A or the specific weight. In this case, we can discover other values like the speed raised to 2 over 2 per gravity, or the weight that is equal to weight A minus weight 2 or weight B. Then we have the HL analysis. In this part, we have to consider that all the pipe has the same diameter. For that reason, we can plus all the 3HL, considering like HL1 is the loss of pressure by friction, the HL2 is the loss of pressure by elbows. In this case, we have to multiplicate per 2 because there is 2 elbows, and the HL3, that is the loss of pressure by both. The next step is clearance of unknowns. In this part, we have to clear other values that we don't know, like the speed that is equal to flow over area, the Reynolds number that is equal to the speed per diameter over viscosity, and the coefficient of friction that is 0.25 over the logarithm of a complete number. The next step is the clearance of HL. In this part, we have two formulas. The first one, that is the friction formula, is for HL1. And the second formula, that is for elbows and both, is for HL2 and HL3. When we make the operations, we will get the results for HL. And in this part is the final result. And the last step is the clearance of PV, that is the unknown of the exercise. In this case, we can use one of the first step formulas, that is pressure B over a specific weight, and there we have the result. When we have that, we can clear pressure B, that is equal to the HL result per the specific weight. When we have the result, we can convert it to pounds square inch, and we will get a result of 22.7 PSE. That is a correct result for this problem. Thanks.